Welcome to solverfy.
Okay, so for 18, we want to show that the given matrix is the inverse of the other given matrix, right? So the relationships then that we're looking for, of course, is if we multiply a matrix by its inverse and then the inverse by the matrix, that both of those should equal the identity. Okay, so we'll start with multiplying the inverse by the matrix, right? So we're given that 2, 3, 1, 1, 2, 1, and negative 1, 3 is the inverse. Okay, so we multiply that by 7, negative 8, 5, negative 4, 5, negative 3, and 1, negative 1, 1. Okay, so if we do this multiplication, right, we take the row by the column, right? And so then this is going to give us 14 minus 12 minus 1 for the first one. Then the same row, but new column. So that gives us negative 16 plus 15 plus 1. And then the same row, but a new column. So that gives us 10 minus 9 minus 1, right? So we move on to the next row and back to the first column. We'll take 1 times 7 for 7, 2 times negative 4 for minus 8, and 1 times 1 for 1, right? And then same row, but we switch columns here in our second matrix. Okay, so that gives us negative 8 plus 2 times 5, 10, minus 1, or 1 times negative 1. Okay, and then we get on to the third column here. Okay, we get 5 times 1 is 1, minus 6, and plus 1. Okay, then our last row and first column. So this is going to give us, quickly, negative 7 plus 4. Hopefully you're sort of getting the hang of how to multiply these matrices by now. So I'm just going to cruise through this last row. Okay, and then if we add all these up, right, so we get 14 minus 13, that's going to be equal to 1. 16 plus 16 is 0. 10 minus 10. We will, in fact, get our identity matrix, right? So in the case where we take the inverse multiplied by our matrix, it did give us the identity. Okay, but then we need to check the other way. Okay, so we need to also check that the matrix by the inverse is also equal to the identity. So then we go ahead and do the same thing. Just changing our order. All right, so we multiply that by our inverse. As such. And then following the sort of exact same process where we start with the first row and first column, we get 14 minus 8 minus 5. And we move on to the next column, same row. 21 minus 16 minus 5. And then the same row, next column. So we get negative 7, negative 7, minus 8, plus 15. Okay, and then we repeat that for the other rows and columns. So then we're getting negative 12 here, plus 10 plus 3. We get 4 plus 5 minus 9. Here we get 2 minus 1 minus 1. 3 minus 2 minus 1. And minus 1 minus 1 plus 3. And again, we will see that this also is going to be equal to our identity. Okay, so since both are matrix times the inverse and the inverse times the matrix equals the identity, then we have proven that